Hey, what's going on, you guys? We got a 2005 Nissan Armada. This one is the four-wheel drive with the 5.6. We are doing exhaust manifold gaskets on this one today and welding up a manifold. So I've already got the driver's side done. Some obvious things you need to do. Most of the work is going to be performed through the wheel well. So pull your tire first and then pull out your wheel well. There are a number of clips and Phillips head screws in a number of places, as well as different clips. These style just pull down and you shove them back in, but they usually don't live beyond one or two times getting removed. A couple of screws down here, then there's one underneath. I've already done the driver's side. Everything is going to mostly be done through the wheel well. These don't take a lot of foot-pounds of torque when you put them back on. In fact, the studs all have to be removed after taking off the nuts. But the driver's side, the gasket was actually blown out on this one. Somebody had replaced the factory gasket at some point in time. In fact, that catalytic converter has been replaced at some point in time. But that is the factory gasket. As you can see, it is, this camera will focus, melted out and burned. Pretty common with these gaskets. Also, all the nuts on this side were loose, which once you torque down the manifold, you need to recheck it, and then I like to check it a third time. New hardware is highly recommended because they are locking nuts, and typically you only get a couple of uses out of them before they will back off. But about 25 foot-pounds of torque is all you need. This is on the passenger side, and I know I got it kind of glowing in here. Let's see if I can get you a better picture in here, but that is the manifold surface all cleaned up. You can see the front two studs can get left in on the passenger side. All the other ones will need to be removed afterwards. All you need to remove the studs is a little E10, and I know you guys are really probably scared of doing this and removing these, but the difference is Nissan, these actually finger in and they take just the slightest amount of torque, like inch-pounds, very, very minimal amount. And so these usually come out with relative ease. If you do end up stripping any of the threads, and what I like to do is pull the manifold and then check every one and make sure that the studs are threading in. New studs are highly recommended. These are actually the wrong ones and will not be going back in there. These are actually for the VQ engine. This is the VK engine, and some of these were notorious for doing this. They got installed with these shorter studs, but they're actually longer studs, and I don't have my package out yet, but they're about that long, so you get a lot more threads, a lot better of a sturdy bite on these. But these tend to come out with relatively few issues. I think I may have had to weld and extract one broken bolt from a VK engine in my entire career with Nissan. Just not a common problem for the studs to snap off inside. These are actually made from a decent sized stud. These are an M10 by 125 thread, and that is on both sides. And of course, now the camera doesn't want to focus. M10 by 125 is your tap size. But in case you need it to tap those threads out, but you will need to remove the heat shield, which I'll show you right here. This one is actually, you can see all the soot where this one was leaking from on this side, but you cannot remove the heat shield until the manifold is unbolted and nearly completely removed before you can get this heat shield out. So this is kind of a clever one from the engineers, you buggers. That what they've done is it's kind of a mechanics test, if you will, to see how good you actually are. But you have to drop the manifold away, pull 1, 2, 3, 4 heat shield bolts, pull out the oxygen sensor, and pray that doesn't seize. But you'll drop him, move him as far down out of the way as you can, and then you have to wrench between that heat shield and the manifold, and it makes it just an absolute nightmare. But if you'll notice where we have soot here and then we have soot there, I'll show you on this manifold. And I know these welds are atrocious. I had a heck of a time trying to stop these cracks, and it was pretty bad split. So we had a bad crack all the way through here. You can see where I've ground down my weld, checking for porosity. You can see all my spatter. Not a big deal. The only good thing about these manifolds is that they are these early generations did have what's called a catafold. So it's the manifold and the cat assembly together. These are going to run you about $1,200. I highly recommend going OE on these, especially if you have a California emission standard vehicle, because a lot of times the aftermarkets will not pass emissions, and then you get to buy the dealer ones anyways, and then pay to have those installed. This one has a date code on it. This was a factory unit. That was a factory replacement that was done in 2015, and this may even been part of a recall for issues that they had with these manifolds, including cracking. But the unfortunate reality is that this is a replacement manifold, and this one actually cracked worse than the factory manifold did. Now, this one has been pulled off a number of times, but you can see again, I had a crack going all the way across, going right along the weld seam and then all the way across the pipe. In fact, I'll bet if I would have hit this with a hammer a couple of times, it would have finished breaking all the way through here, because we had a split coming all the way up here. It was split down the weld and spidered out here, and then you can see down in there it spidered out on the back side, continued all the way across, and it was nearly all the way across this thing. And then we had another horrible split right here up the middle of their weld. And then I had quite a few pinhole leaks up here at the top that I had to retouch up. And then we had a spider coming up this way, a spider going out this way, and then a spider headed back towards the flange. And so that one I did end up grinding that away to eliminate any issues with getting that stud in, and also with getting the nut back on that. And if you want, you can grind these back to almost flat, but this metal is not all that thick. I don't recommend too much temperature in this. If you end up putting too much temperature in it, I've actually got some high spots in here where the weld bead actually protruded into the pipe, and that is going to reduce power, performance, and flow, but hopefully I will be replacing these with long tube headers at some point in time here in the future. But yeah, this is what you guys are looking at. When you go to extract it, there is one heat shield right there that does need to be removed in order to remove the manifold from the vehicle. And I'm going to bear with me here. We're crawling under the vehicle so I can get you a better angle of what you're looking at. There is the Y pipe going back, and generally I recommend unbolting both sides in order to get that manifold off, and then the manifold needs to come up in order to get past these, and then you'll drop it down here and back. But this is that heat shield right there. It sits like that in the vehicle. And there are two nuts. You can see there's the studs, 1, 2, that needs to be removed. And then that manifold just slides up in. It's kind of an advanced game of Tetris, but super simple to do, not bad at all. And you just got to figure out the right moves on your Tetris game, and it'll drop right out of there. But before you put that manifold in, that heat shield needs to go in like 3/4 to half of the way up in first, and then the manifold can go in, and then they kind of both go in at the same time. I don't recommend, you might be able to install it better if you put the heat shield on the manifold and then retake it off when you go to bolt the manifold to the block. Make sure you go in sequence with the torque spec, and I will try to show that to you here at the top. Basically start from the middle and torque your way out. You want to finger everything down and make sure it's sitting flush up against the block when you go to tighten it down. And then what you want to do is start with the two centers. And so you'll go, so you can see there's the very front cylinder. Here's the next one back, 3 and 4. And so where we're going to start is right there. We're going to torque him down, and then him down, and then up here to that one. And then we're going to go all the way across to the bottom corner, and then back over here. We're going to hit the, let's see, yeah, we're going to hit the other back corner right there, and then we're going to come back to the front. We're going to torque that upper one to finish this side, and then we're going to torque this upper one to finish that side. I want to say the flat rate called out something like 1.7 hours or 3 hours, something like that, to do one manifold. Expect at least 6 hours if you're doing this yourself and you're not an experienced mechanic. Even with all my years with Nissan, dropping that manifold out only took about an hour for me to do it. But then with cleaning up the mating surface, welding up the manifold, and that probably took me a good 2 hours, taking my time. And you want to weld this nice and slow So what I like to do is start at the tips of the cracks and then weld. Bye-bye. Start at the tips of the weld right where it cracked and weld a little bit on the other side of it, and then go to the other side and weld that up. And then from there you can kind of start working it together, and you can weld in about a 1/4 inch bead at a time. You just want to really let this manifold cool down. If it starts getting cherry red hot, a lot of the times it's pushing that weld inside of the pipe. And where it will still be a good weld, you're going to lose a lot of flow out of these things, a lot of performance. But yeah, just take your time welding them up. If you do decide to weld them up, it's a lot cheaper to weld up a manifold, especially if it's not throwing a P0420 or a P0430 code. If the catalytic converter is still okay, no reason to throw it away, especially where we can weld these manifolds up. Just do a clean job, and then I highly recommend, I did make a YouTube short on this one, but what you want to do is actually take duct tape across the whole face of this thing, tape all this off once you've got this all cleaned up, put some duct tape across there over the oxygen sensor hole, and then 2 pieces to cover the collector post-cat, and then you're going to poke a smoke tester into it and then fill this whole thing up with smoke with a little bit of pressurized air. And what that's going to do is it's going to show you all of your pinholes. So I got this thing welded up, thought I had it pretty good, ground down some of it to make sure there was no porosity and everything was good. Went ahead and smoked it, and I had about 8 different little pinholes. And every one of those things has a liability to create a tick, a ting, or a puffing exhaust leak. So, which can be hazardous to your customer or to yourself. So highly recommend smoking this to verify that you got it right the first time, so that you don't have to install the manifold, fire it up. Here it's still ticking, still making ruckus, and then have to pull it back out and re-find your cracks and your pinholes and re-weld it up again. So a lot easier just to smoke test it and make sure that it's completely sealed. Overall, not too bad. I think I'm into this now about 5 hours, and we are just beginning the reassembly procedure. So make sure to sell yourself enough time for it. A lot of the times I will pre-advise my customers as well, in case of any broken exhaust bolts or cross-threaded holes that we will need to tap, that I will advise them that it can be as much as an additional hour per bolt that we have to correct. And I will let them know that ahead of time, and that there's no way to know until we get into the job and we've got the manifold pulled off before we'll know how much more additional time we'll need. But for welding, I usually sell 2 hours to weld that manifold on top of the removal job as well. So overall, not too bad. Any questions, any comments, feel free to leave them below. I try to answer them as quickly as possible, but sometimes YouTube likes to hide them from me. Either way, have an excellent day, you guys, and enjoy your weekend.